Hi folks, my name is Sumukh Sridhara. I'm going to be chatting about building SaaS products with Flask in this workshop for FlaskCon. The outline for this workshop comprises of three phases. The first is we're going to build an understanding of what makes a SaaS application and what we would need to do to build each part of it. Then we're going to go over an ecosystem tour of relevant Flask tools and libraries that will help us build this SaaS application. Lastly, we're going to put those all together into a real SaaS application that we can build with Flask. Specifically, what our application is going to look like is something like this, where we have a sign-up page, a sign-in page, we support OAuth, and we can allow people to log in. Once they're logged in, we'll allow people to There we go. Once they're logged in, we'll allow people to upload files into a shared folder in the SaaS application. They can invite team members, and they can even upgrade their billing, etc. We're not going to build all of it in one workshop, but we're going to focus on the key parts of how we go about building it and where we're pulling together all of the tools. The actual functionality of this web application is it's going to allow us to watermark files. So we can type in some text here, upload a PDF, and it would watermark it for us and give back to us. Great. With that, let's get into a little bit about myself. I lead product and engineering here at AngelList Venture, and we have a couple of internal tools that are written in Flask, but the majority of our stack is not. In prior roles, I've built a few large Python Flask applications, and I'm also the author of the New Line course called Full Stack Flask, which goes over building a full SaaS application using Flask as well. In my past, I used to help teach the introductory computer science course at UC Berkeley, and here a lot of students were using Python to learn how to program, and they ended up using Flask as a simple way to turn their programs and make them online, but they often just stop there, and they heard that they need to use larger frameworks if they want to build something more serious or more functional than a simple test application. And part of the reason why I wrote the Full Stack Flask course was to help show that it didn't have to be the case, and actually that Flask can be great for building larger applications as well. You can find me on GitHub at Sumukh or on Twitter. I'd love to hear your comments. I'm based in San Francisco, so unfortunately the time zones for the conference didn't work out, but I'd love to chat sometime if you have questions about Flask. So my first part of this is going to be defining what software as a service is. And to really consider what software as a service is, you have to go back in history a little bit and consider how software was delivered 20 or 30 years ago. And if you bought software then, oftentimes what people were doing was they're sending CDs in the mail to you to install on your computer. Or if you go back a little further on floppy disks, and the point was there were not online hosted applications that you could just navigate to and use. A software as a service, on the other hand, is a hosted service that delivers software. And there's a lot of advantages of that. One of which is you can instantly do updates. And second is it's easier to make that software multiplayer and allow other users to collaborate and interface with other APIs as well. So some examples of those software as a service products include things like Buffer, which is a way to schedule social media posts. The very first versions of Buffer were actually a fairly simple PHP web application and a cron job to post tweets. And they've expanded their product from there, but that's a classic example of a software as a service application. They now allow companies to schedule their social media posting and view analytics, among other things, and they charge a recurring monthly fee, which is a typical SaaS pricing model. They've now built a business that does millions and millions of dollars of revenue off the core product here. Another example is Canva, which is a hosted design tool software. So people use this product to create graphics, and it's all hosted on canva.com. And you can think of this as the SaaS version of Photoshop for some people, where they're using it to design graphics, but instead of downloading software, they're doing it all in their browser on hosted software, which is interesting. There's tons of other examples of SaaS products that I can go into. You probably use quite a few in your day-to-day life, but I will leave it there. And what we can think about now is we can think about what it is you need to actually build a SaaS application. You first off probably need to store data somewhere. So you need to set up a database to store your records, whether that be tweets that you're scheduling later or even storing information about users. You need to be able to do user authentication so you can host information about your users. You likely have many customers using your single hosted product, so you need to be able to securely gate access to certain parts and certain data in your product. And then the third one, which is fairly tricky, is actually deploying your application and hosting it in a reliable manner so that anyone can access it at any time. And you're probably thinking of some other things that you need to right now. And that's right. There are quite a few other things that you need to build a SaaS application. Permissions, for one. Sending emails, because to sign up, whether for marketing reasons or for application reasons and transactional emails, you might need to build a test suite. You probably want to build a test suite. You might need to do delayed jobs for jobs that are too complicated to be done in a context of a single web transaction. You probably want to run database migrations to be able to make upgrades to your database and schema over time. And then that's not it. There's more too. You might want to have authentication from other services. You might need to integrate into other services. You might need to do email confirmations and invites of users. You might need to manage teams and permissions for teams. Depending on the kind of SaaS, you might also need to let users have an API token to make queries on their own data, or you might need to integrate with other services like Zapier or others to give more tools to your users. You probably want to build an admin dashboard as well so that your team can quickly edit data. For example, a customer asks to change the email on their account. Instead of you building a tool, you might want to use an admin dashboard there. And then there are things like recurring billing, which is complicated itself in order to be able to charge users $10 a month per user. And new regulations might mean that you have to support doing data exports as well. So this isn't by any means a comprehensive list, but the takeaway here is that it's just a lot to manage to build a SaaS application. And this is part of the reason why some people think you need to use a large web framework, because the large web framework has thought about many of these things. The challenge emerges when you grow and scale, and we'll talk about that in a little bit. The next natural question you'll think about is, if Flask is a micro framework, why wouldn't you use something heavier and more designed for building large applications in the first place, like a Ruby on Rails or a Django? There are a couple of reasons, and a lot of it relies and comes out of the fact that Flask is extremely simple and understandable as a framework because of its design as a micro framework. It's very easy to understand what is going on under the hood compared to a random application in Rails. There's not as much magic happening behind the scenes. And this is one of the most common complaints of beginners who are running Ruby on Rails, is that there's just so much magic happening behind the scenes that you don't understand what's going on. With Flask, it becomes a lot clearer about what's happening. So you can drop a new engineer on your team into a Flask application more simply than you could in a random Django application if the engineer has never used Django before. The ramp-up time, therefore, is a lot more efficient. Secondly, it's more extensible. So many of the tools and larger frameworks come built in with their own built-in view on how you do something. For example, an ORM. And if you want to or need to use a different ORM for your application, it's extremely hard to rip those out of the core framework and choose your own. Whereas with Flask, it's an easy, extensible way of just adding the things that you believe make sense. I've seen this happen a lot where a framework will implement a solution for real-time WebSockets, for example, but for whatever reason, that specific framework doesn't work well for your application. And then ripping it out and building your own one on top becomes incredibly hard and complicated, or forking their implementation. It becomes messy with a lot of monkey patches everywhere. So instead, Flask allows you to just choose the library that best fits your need. It's performant enough because it's simple, so there's not going to be layers of framework code that are between you and getting to something efficient, which does happen in larger frameworks. Then most importantly, it scales with you. The way I like to think about it is, as you're getting started, you want something that's easy to get started with and understandable and will help you move quickly. Then you want something to help you scale and grow your application. And lastly, as your application reaches a large amount of scale, you want to be able to quickly manage specific components of it. I think Flask is very well suited for the first and last stages there, where it helps you start with something simple and understandable, and then it helps you as you scale. The real benefits come in the later part, though. As you're building larger and larger applications, you'll appreciate more and more having used Flask. And you might be wondering, well, these large frameworks come with all these tools to help me not have to re-implement the wheel. And you're right that they do, but fortunately, Flask has a strong ecosystem of tools that we can work with. So in this next part, I'm going to go over an overview of Flask libraries and tools that you can use to build your SaaS application. All right, so here's the quick overview. Before we get started, I'm going to mention that this is a subjective review. There are probably lots of libraries out there that solve similar problems that are great. These just happen to be the ones that I've worked with and can recommend. If you have thoughts on what other libraries do a good job of solving these problems, please feel free to put them in the chat so other people can find them as well. So first off, the most core thing here is that you have a way to talk to your database. So Flask, SQL Alchemy, and SQL Alchemy are great ways to do that, and is my preferred ORM when I'm writing applications using Flask. It solves things like doing database connections, writing SQL queries, writing models, and being your ORM to interface with the database. But one thing it doesn't do, for example, is it doesn't necessarily solve migrations for you out of the box, and you're going to have to use other libraries, which we'll talk about later, to do that. You can check out the library at Flask SQL Alchemy. It's a Palettes project, which is great. And here's a quick overview of how you might use Flask SQL Alchemy. So the first step is you're going to define your models here. So you're going to, for example, for a user, and you're going to find the attributes here. So the ID is an attribute here. It's going to be an actual column in the database of integer type and primary key. Similarly, for username, it's a column with a string, etc. And depending on the kind of underlying database you're using, for example, MySQL or Postgres, you might have exposure to other kinds of types, or you may have specific kinds of requirements about specifying the length of strings, for example. SQL Alchemy will work generally across most databases that you can find. So here we've defined a few other fields, and then the next step is you will build queries using SQL Alchemy. So here's a query which will help you essentially run a where statement where select all from users where username equals admin, and then it gets you the first result. And so on this, you can now do um, email, for example, and get the email of that associated record. Next up, I want to talk about login. So doing login is kind of complicated. You manage a lot of it in Flask, in the session that Flask exposes to you. But instead of managing all of that for you yourself, it's better to use this library called Flask Login. It'll help you do login, logout, overall session management, which includes things like remember me as I'm logged in. It also helps you protect routes and ensure that you are logged in. What it doesn't natively solve for you itself is solving permissions. So if you need to implement policies about which users are allowed to see this record, Flask Login doesn't necessarily help you there. It's more of the infrastructure layer of how you do login and log out. So the actual usage of Flask Login looks like this. Flask Login imports, it uses a couple of things. There's some other setup here that I'm not showing. These are intended to be snippets to give you an idea of how the libraries are used. You can decorate routes with this decorator called login required. And what that does is if the user is not logged in, it'll actually redirect them to the login page. And you actually go and configure that route name elsewhere, but it'll redirect people. And then if they are logged in, they'll be able to access this route here. And the current user field will actually return, if you set it up that way, to return the actual name of the or the actual user model here. And so you can do user.attribute. Here we're doing user.name, but you could do .email, for example, and get their email. And that's a very quick way, because otherwise you'd have to write a lot of queries in the middle and logic to get there. And this is a really quick, nice shortcut. In addition to doing login, you may want to support login from other providers. So for example, you may want to support that login from Google. And normally the process of building OAuth is rather complicated. There's a lot of steps involved. And one of the nice things about Flask Dance as the library here is that it makes it very simple for you. It's a wrapper around OAuth lib, which is the underlying framework that does a lot of the work, but it makes it super simple for you as the Flask developer interface with OAuth, which is normally pretty complicated. It helps manage all of the token and login flow, but what it doesn't do for you is it doesn't let you become a OAuth 2 provider. So if you want to let other applications log in with your website and your authentication, it doesn't let you do that, but it lets you help implement login on your own site through other providers. Comes out of the box with a lot of existing providers like Google, GitHub, Twitter, etc. So it becomes really easy to do that. For example, to use a GitHub OAuth login, it's fairly easy. All you do is you specify your client ID and client secret that GitHub give you when you create an application there, and then you register a blueprint, and then you're basically done. There's a couple other setup parts involved here, but Flask Dance makes it the simplest of all of the libraries that I've seen to do OAuth. Next up, one thing that defines a lot of SaaS applications is they have a lot of complex forms. So those forms often have a lot of validations in there, and building all the logic to render the validations and error messages can be a little daunting. Another thing you need to do from a security perspective is protect from cross-site request forgery, which Flask WTF does. It is a wraparound WT forms, but it adds nice things here like CSRF protection and the ability to quickly do reCAPTCHAs to prevent bots from using your site. And it helps you integrate all of that really simply and bring it into the world of Flask as well. So it comes with this idea of defining your forms like objects here. So you can say what is your form? Similar to how we define them in SQL Alchemy with our models, we're just defining the fields here. And we can add validators here that show us what we need. An example of another kind of validator that's not pictured here is validating that the input is actually a valid email address. And you can build your own validators as well. And Flask WTF will actually validate those forms here. So the route you see underneath is an example of a simple form that will, when it gets a post request, will actually validate it. And all of the data in the form is available to you at this point under form.data. And it becomes much easier. And it's also coerced into the right types, which can be another nice thing and make your application code a lot simpler. Now, to render the form, what we do is we actually pass in the form itself into Jinja, and we have a special syntax to render the fields of the form. So the fields of the form here include form.name. So that was this field here. And what we do is we render the name of the form and then the actual field here. And so we can pass in parameters like size, which get added as an HTML attribute. This way we don't have to write all the HTML boilerplate. It's like, form input equals type, whatever, and all the other attributes. This will just handle it for us. Another nice thing is it will handle error code protection and rendering error codes. So for whatever reason a validation fails, the validation errors can actually show up in the front end after a submit, which is really nice and saves us a lot of time as well. The other thing it does here is it includes a hidden input tag for that cross-site request forgery token. And implementing all of this yourself, for example, would have been pretty complicated and not necessarily worth your time when you can just use something like Flask WTF here. Next up is something that a lot of SaaS applications do, which is send emails. Flask Mail is a good library here. It helps you send over SMTP. And one thing I'd recommend here is you use an email provider service like Mailgun or SendGrid or Postmark to help you actually send emails. They'll provide you with SMTP credentials, and it's a lot better than using, let's say, your personal email address as SMTP credentials, even in development environments, because they have reliable email sending environments, and it can be a lot better to test with them instead. Flask Mail also includes attachments and lets you send bulk emails as well. Now, things that it doesn't do for you is it doesn't solve style inlining. So if you've ever sent HTML emails before, you know that emails have a weird formatting and use a lot of tables and inline CSS styles, and that's a result of how mail renderers have worked. So you can use this library called PyNliner to inline your CSS and HTML for email specifically. Unfortunately, Flask Mail is not maintained, so you might want to explore alternatives. I haven't explored them as thoroughly, but Flask Mailman looks like an interesting alternative here. I should say Flask Mail still seems to work, but that may not be true in the future. An example of the usage here in Flask Mail is you initialize the mail app and then you create and construct a message. And so here the message is a simple email with no body that just says hello and has a sender and recipients. If you wanted to construct an actual body, you could pass the results of render template here as the body, and that would render actual HTML contents for the body. But it's as simple as mail.send. Another thing Flask Mail does not do for you natively that you might want to do is you might not want to send the mail immediately. You may want to send it as a delayed job. And we'll discuss how to do that later in this. Another good thing for performance and for reliability is actually caching. And Flask caching is a good library here that helps you implement caching both at a route level to cache the results of an entire route or just single functions, and memoizing them, or even caching partial Jinja snippets here, which will increase the performance of your application. You can find the library here in Palettes Eco, and it supports multiple backends. The one I use most often for this is Redis as the backend, and we'll chat a little more about Redis later in this as well. The actual usage is fairly simple. Here's one to just chat about Flask and caching entire routes. So this caches the results of the entire route and saves it in memory so that you save all the logic that goes through render template. You only do that once every 50 seconds. You can do additional logic here to like only cache the page for logged out users or only cache the page for a specific user. And those are all things you can do. You can also cache inside of a Jinja partial or just a specific function. Another thing applications have a lot of oftentimes is assets. They have CSS and JavaScript in different kinds. They may have one kind of CSS and JavaScript for the landing page and one kind for a dashboard. And they might have different kinds of dashboards that need different kinds of CSS and JavaScript. And so you also want to minify these assets in production. And maybe you don't want to introduce another tool into the ecosystem like Webpack if you don't have to. And so Flask Assets is a wrapper around Web Assets, which helps you construct asset bundles and use those bundles in your template. So here's an example of us constructing a bundle. This is us including a bunch of JavaScript files here. So jQuery, application.js, whatever you want. And it gets output into a specific file. And in your templates, you can actually go ahead and call this assets tag and have it dump the assets into the right place by just doing something like asset URL in there. Now, what it'll do is in develop mode, it will actually just directly link to those files and use Flask routing to get you there. And then in production, it'll link to the compiled version. And it'll help you do things like cache the compiled files in production or run JSmin, among other things, to get you a minified version of the CSS or JavaScript file. So Web Assets is great. I've enjoyed using it on all my applications where I'm not using Webpack to get a lot of the benefits while still maintaining being in Python world. You may need to build an API for your application. I've personally enjoyed using Flask RESTful. It solves input argument parsing and validation. It handles output and things like error handling as well. So it's a very powerful set of tools, and it makes writing APIs pretty easy and pretty fun. So here's a simple API example out of the documentation for Flask RESTful. It's a quick example of doing a in-memory database here where you are returning the result of fetching something here. So you pass in to-do ID, maybe 1, and it'll look up the value in the dictionary for you, which may be none in this case. Or you can write things by submitting a put request to this endpoint. So if we submit a to-do ID here, we can just store the thing here, and it will store it in the dictionary, and then we can retrieve it later. So this is a super simple API. It doesn't do any input validation or argument parsing or marshalling. What you can do in more complex applications is, for example, marshal the results of an object. So if you're doing a database lookup, all you have to do in this return statement is you can return, for example, the user object and specify that you only want to marshal out the ID and email of the user. So despite you returning the user object, the only thing the API will see is just the ID and email, which makes it a lot easier to build applications, because then you don't have to construct a response for every single kind of API query. Here, this is an example of manually constructing the output, which Flask RESTful also lets you do. So Flask RESTful is a pretty powerful API tool to build REST APIs if you're doing that as well. And if you're using tools like GraphQL as well, Flask has tools in the ecosystem to help you. But I'll leave those out of this specific workshop. Next up, once you have an API, you may want to consider things like rate limiting requests to your API. Flask Limiter is a very simple, lightweight way of doing that, where you can specify overall API requests so that your server doesn't get overwhelmed or abused. And so it supports implementing a variety of backends. Again, I think the one Joe will go with here is a Redis backend because we use it all over the place in the rest of our SaaS application. Here's a quick example of what that implementation looks like. So basically, you pass in a way to identify users. So this get remote address will get the IP address of users, and you can create limits either on routes or global limits to specify how often someone can make requests to your API, and if they get too much, they'll get hit with the response code for too many requests, which can be helpful and is a lot easier than you building that logic yourself. Next up, something that a lot of Flask applications or SaaS applications do overall is file storage. So you may want to upload your large files into S3 or Google's cloud storage, among other providers. Flask Cloudy helps you do that, and it supports a variety of these providers. You can upload, download, and get the object URL for files across all of these services, and it's pretty simple to use. Basically, once you get an upload, you basically call storage.upload once you've configured the secret key and auth for the underlying cloud storage library, like your AWS S3 API key or API secret. And then you get a bunch of objects, and so you can just redirect the URL or save that in your database somehow. Next up, we talked about delayed jobs before. So delayed jobs are jobs that you might want to run outside the context of a specific web request. So things like a long-running business report or a job that doesn't belong in the core request flow, but needs to be done regardless. For example, sending a transactional email. And RQ2 here is integration with RQ, which stands for Redis queue, which is a library for Python to build job queues. And RQ is a very simple, lightweight job queue that you can work with. It is easy to understand. There are other job queues out there like Celery. I find that those are harder to understand and often overkill for what you need. And so I find that Flask RQ2 here comes up with the best developer experience. So to define a job, you create a function, add the decorator in there. So here's a very simple job that just adds two numbers. You can imagine the job does something else like send an email or run a long query. And the way to do it is you can just do add.queue here for these numbers, and it'll run the job in the background against the default queue that workers are listening to. You can also delay the job, so you can say, I want to run it in 60 seconds from now, or you want it to run at a specific date and time, or you can set it up as cron jobs to be recurring constantly. And RQ supports all of these, and it's fairly easy and simple to do that. In addition, RQ also has an admin dashboard that's pretty easy and simple to work with. Next up is migration. So as you're building a SaaS application, you probably won't get your schema right from the first time and build all the features correctly and build a fully functional app from day one. So you're going to want to have to change the database as you go. And instead of running ad hoc scripts to do that, the best way to do that is use Flask Migrate. And Flask Migrate is this library that uses Alembic under the hood and integrates with SQL Alchemy. And it automatically picks up model changes that you've made. So if you had that user table or model defined and you add a new field in there called last name in there that you didn't have before, Flask Migrate and Alembic can pick up that you've added that new field in there and generate an appropriate migration file to add the column into the database. It exposes all of its commands through FlashDB and is a great tool. The quick interface here is you run FlashDB migrate to generate the migration files, and Alembic goes in and generates actual files with the upgrade and downgrade function. And those functions run commands to actually add columns or delete columns or change columns in the database. And you can manually control those columns, but oftentimes it's going to pick up exactly what the right change to do is. And then you just run a FlashDB upgrade on the production machines with the production database, and that'll actually run the migration. This is incredibly important as well when you're working with multiple developers to ensure that everyone has the same version of the database that they're working against. Now, speaking of developer tools, another thing that's really useful here is called Flask Debug Toolbar. Flask Debug Toolbar allows you to do performance tracing, query analysis, and other kinds of debug information as you're developing your Flask application. So what it does is it injects a little bit of HTML into your application, and what ends up coming through is there's this little sidebar here that pops up, and that sidebar tells you a bunch of information about the application. So here it's showing HTTP headers and config, but it does other things like your SQL Alchemy queries and what templates you were used and the request variables for this specific thing. And at the bottom, you'll see that thing called Profiler. And Profiler is really interesting for performance tracing. If you turn that on, it's going to give you essentially a flame chart of where requests were made and how long requests took in each part of the stack. So you can see if there are particularly slow functions you've written or functions that are called way more often than you think. It's incredibly nice from a developer tool experience perspective, and just to get a sense of the performance of your application. Now, of course, you're only running this in your dev environment, but it's still extremely useful. Other things that you want in your dev environment are testing environments. So Flask testing makes it very simple to test Flask routes. You can pair this in conjunction with PyTest or unit test or some other of the Flask testing libraries, but you can build these test cases that essentially say, we're going to go make a request to this, and we're going to ensure that the API looks exactly like this. And so it's a bunch of helpers to make testing a lot faster for your application. You don't have to use it, but I find it makes writing tests a lot faster as well. And then the last one here is that when you're building SaaS applications, you don't want to necessarily build for every single possible use case. And so there may be things that you want to update or your admin support team needs to update that you don't necessarily need to build as an engineer. And Flask Admin is a great one to use there. It's a set of tools that can allow you to edit, create, update, delete records through a UI that Flask Admin makes. And it hooks into SQL Alchemy models really well. So you can very quickly create a dashboard just for admins on your application to edit models or create new records. So here's an example of what that UI looks like with the user model hooked in. So you can see here there's two fields, username and email, and people can either create, delete, or update those records. And this is extremely useful so you don't have to build all of the tools yourself and all of the create, update, deletes for things that are not user-facing. Okay, with that, we're going to go into the implementation section of this, where we're going to actually go ahead and pull together all of the things we talked about here to build this actual application now. Okay, so to start off our implementation, we're going to go ahead and download some starter code, which I've already put together. Now, this starter code pulls together a lot of the library kits that we've been talking about, along with some others that help us develop our Flask application. We're not going to use all of them, but we can treat this as a starting point to help us save some time on integration and help us focus on the parts of our SaaS application that are actually relevant to us specifically. So the first thing we're going to do is we're going to go ahead and download this repository. We're going to clone it and go ahead and create a virtual env here. So I'm going to go ahead and start by cloning the repository, which I've done here, and then we're going to go ahead and create a virtual environment here. The virtual environment is what we're going to use, and we're going to activate it. Once we have that installed, we can go ahead and install all of the requirements. So we're going to let it do that, and we're going to go back and look at what some of the ones that we've started here are. So you can see we're using WT Forms, debug toolbar, login, caching, Flask Dance with the SQL Alchemy adapter specifically, Flask Mail, Flask Admin. We're going to use Postgres or SQLite here in development. We're going to use SQLite along with some other tools to help us here. All right, let's check back in on the installation and see how that's going. Looks like that's still happening. So why don't we take a quick look at the files that we're working with and what the structure of that folder is. So you can see here we have a top level folder that contains our requirements.txt as well as a bunch of other information. And what we do is we have our app here, which gets initialized and sets up the function and initializes all of the things like the debug toolbar, etc. And it has a controller here, our routes and our blueprints. So for example, our auth blueprint. And here we're actually setting up Flask login to be able to fetch the user object as well as login routes, among other things. And you can see us using Flask limiter, etc. So this is essentially all boilerplate code. And you can see we have some forms here. What I'm going to go ahead and do is I'm actually going to go ahead and start working on some of our new forms that we'll need. One of the forms we're going to want to build is a form to allow people to watermark files, since that's the application we're building. That actually looks very similar to this file form, so I'm going to go ahead and duplicate it, and I'm going to call it watermark form. And what we're going to do is we're going to accept a watermark text here, and then we're going to keep this attachment here. One thing we're going to do is we're going to add this validator to ensure we get a watermark as well. And now we've created a watermark form for us. Next up, we're going to go ahead and create all of the tools we need to actually modify PDFs. So PDFs are some of the things that we're going to require an external library to help with. So I'm going to go ahead and create this helper file here in pdf.py. And what this does is it uses these two libraries called PikePDF and ReportLab to watermark files. And there's a bunch of helper functions here. Let's go and check that those are in our requirements.txt file. It looks like they are. So let's go and add them as PikePDF and ReportLab. And then we're going to go back over into our terminal and go ahead and install those. So we're going to run that command again and install those two libraries here. Great. So looks like we have those libraries and we can get started with running our application. If we look at the instructions in the README file, there's a way to set up the database to actually be initialized. And so we're going to run that command next. So here, and you can see right here under reset DB, we've created this command that helps us actually reset the database and seed it with some users. So you can see here the login is user at example and test, and admin at example.com and test, and that creates some users here. We're going to go ahead and run that command here in our terminal. So we're going to run manage.py, and then we're going to do reset DB. This is going to go ahead and create a local database here. So you can see inside of here, it's created a database.db file, which is our local SQLite database we'll be using for testing, which will work just fine for us. Now what we want to do is we want to run the server. There's a handy command here in manage.py to actually run a server, but you can also use the Flask run command. Looks like I'm already running a server, so I'm going to go ahead and fix that in a sec. Okay, well now we're running a server, and we can load up the application on 127.0.0.1 and port 5000. So let's go ahead and go over into our browser and pull up that URL. Already have a session stored, so you can see what it's actually going. But it sees here we have a sign up and we have a bunch of information here. One part of the boilerplate here is it's actually already designed to ingest some environment variables, like for Google OAuth. If we, for example, set all of these environment variables beforehand, that will actually go ahead and be used by our application. So I'm going to go ahead and set those in my environment really quickly and then restart the server. Okay, now that I've set those environment variables in my terminal, as I refresh the page, you'll see that now we can see sign up with Google is already configured. And this implementation was actually fairly simple because of Flask Dance. I'm not going to go into the actual implementation for the sake of time, but you can check out the source code and see how it is actually implemented. So since we already have a user account here, what we can do is we can sign in with that user account. I'm going to sign in with the admin account here. So admin at example.com and admin. And I'm in, and I get this sample dashboard, which is what the boilerplate comes with, but it comes with a bunch of things like teams, user settings, etc., which is nice. I'm not going to go into too much detail about the boilerplate because that's not what this talk is about. Instead, we're going to focus on the integration and seeing all these things being actually put together. So, for example, you can see that there's an admin URL with the Redis queue dashboard, and I can spin up workers to do jobs here, or I can go to /admin and see a Flask admin to see a user panel here. So I can go ahead and check out which users are here, check out all of these fields, and all of these fields, including some of the relationships, are coming automatically from Flask admin, so I can check out some of these things. It's a useful tool. You can do exports, you can do search, etc. And it's fairly easy to add in other columns. Specifically looking at some of the code, all the code we wrote to implement that was just this user view. We defined this user view, and then we added it to the dashboard. And similarly, we can add other views as well and quickly get them in the actual admin dashboard. So Flask admin makes it fairly easy for us to work with tools, and it's a useful kit in our application development journey. Okay, so going back here, we have a bunch of tools. We have our OAuth, we have other things here like billing, and we have account settings and changing passwords, etc. So our goal here is we're going to go ahead and create a form for people to upload files and get them watermarked. And we already have this tool here that allows people to upload sample files, but we're going to go ahead and do something more specific around watermarking for our SaaS. Our first step is we're going to go ahead and get rid of all of this sample code in the dashboard and build our own one. So here's that template file. I'm going to go ahead and knock out everything in here that's not the starter code. Perfect. So now we have a very simple dashboard. Let's go back to our page and refresh it and see what we get. Perfect. So we get a blank page, which is a perfect place to start. Our next step is going to be rendering that form that we just tried. So here we have the form we just defined. It was in files.py in the forms folder. We're going to go ahead and go into our dashboard, and on our home controller, we're going to go ahead and import both the form as well as watermark PDF, which is that function in pdf.py that defines a lot of the actual watermarking we can do, which here is watermark. So we're going to create a new route here that allows people to submit files. So let's go ahead and call this submit for watermark. And we're going to go ahead and here we're going to call the watermark PDF function. So the idea here is that someone is giving us the form and submitting it. So we're going to say watermark form there, and then we're only going to accept it if the form is valid. So if the form is valid, we're going to go ahead and validate it here, and we're going to get the new file here. We're going to call watermark PDF with the data from the watermark parameter, which is this one, the text field. And then we're going to go to get the data of the file they provided, and we're going to pass that into the watermark PDF function. Now this next part is going to involve me pasting a little snippet of code to help us actually watermark the thing. And it's not particularly interesting, but I will paste it in here anyway. And I'm going to have to import some things here. So temp file and send file from Flask. And then we can import, we can abort if it's not a valid. File. Okay, so what this should do is on submissions to this form, it should validate and submit. Pretty straightforward. And then what we're going to do is we're also going to pass in this form into here. We're going to call this watermark form. There. And we're going to go render that on the front end in the dashboard homepage. So I'm going to paste in some code here using WT forms. And what it's going to do is it's going to create a new form in here that will make a post to the method that we created here. We call it submit watermark. So we're going to call it there. And what it does is it uses the form and it renders the hidden tags, so the CSRF validation, and it renders the two fields, the watermark and the attachment. And we're going to have to do a little import here as well to get the render field macro that we've defined elsewhere. Let's go and check out how this looks in our application. Great. So it looks like we have the watermark file route working and this actual text working. So let's give it a shot. So here's the actual UI that I just saw. It looks like both of these are working, so let's try an actual submission with them. I'll upload a sample PDF. Let's give it a shot. This may not work. This is the first time I'm trying this. We gotta fix the method on the... So we're gonna make this a post really quickly, and of course there are other ways to make that happen, but we're gonna go with this for now. Great, so I refreshed and you can see here that the file is created and is actually watermarked with what we actually add it to the page. It's pretty neat, and it's a cool product, but it's unlikely that we can sell a SaaS just for doing this one function. Part of the value of SaaS products is that they are collaborative and let you store and save things. So what we're going to do next is we're going to go ahead and make this actually save to the cloud using Flask Cloudy that we just talked about earlier. For the sake of time, I've already implemented the model that we're going to use here. So we're going to call it team file, and it's going to be referencing an object here that we're going to use in Flask Cloudy. It's going to be associated with the team, which is a concept in our SaaS boilerplate already. And that will allow us to store files that people already upload. So in order for us to get there, we're going to have to first import storage in our tool. So we're going to go ahead and import from app name .extensions, import storage. And if you're curious what extensions.py looks like, it's basically this file where we set up all of our Flask extensions. So we're going to import storage there, and then we're also going to insert team file. So from Flask models.team file, import team file. And we're also going to import db because we're going to need that. Now that we have this, what we want to do is, instead of just returning the file data here, we're going to want to upload it to the cloud. So what I'm going to do is I'm going to do storage .upload of the file path here of the temp file, create a temp file record, and I'm going to use current user from Flask login, the form from attachment from WT forms, and the actual file name, among other things. And we're going to add that to the database, and then we're going to rewind the file objects. That way we can still send the file back to the user. Let's go ahead and give that a shot. So as we're in the application, we can go ahead and try other things. Oops. All right, I just restarted the server there, and looks like we're going to have to change a setting here. So let's go back in our code base, and let's check out how we're managing settings in our particular application. So Flask Cloudy has this concept of allowed extensions. So we're going to want to go ahead and do that ourselves too. So we're going to have to set storage allowed extensions here as a variable, and the Flask app picks up off of this environment variable here. So I just resubmitted it, and hopefully we should see on the other side it actually be stored in our dashboard. And I just pulled up our page, and it looks like it's actually submitted. So this allows us to create essentially a team Dropbox, and we can add more things here. So for the sake of example, there's a couple of other functions that I've created here in the code base for pdf.py, and there's an extension an exercise for you if you'd like to extend this code base to, for example, create a password PDF protector or a form that concatenates PDFs. You can assemble that all into the SaaS application we just built and then sell that yourself as a tool. Obviously, this is a lightweight example PDF for example cases, but we can talk about what it would look like to actually get there. So let's say you've built out all of that functionality in your dashboard and you have shared files. What you can actually then do is you can go ahead and create billing. So here I've created admin's team, right? And so you can create a billing for that team. And that billing could be based on a number of things. For example, could be based on number of users that are allowed to be on your team. So you can send invites, and once you exceed a certain number of invites, those people aren't allowed to be adding new teams. Or you could create limits on the number of files that you can do per month. Or maybe the yearly plan has access to your API, for example. So these are all things that are possible. For the actual billing implementation, what I've done is I've worked with Stripe, and so you can hit a few buttons here and actually get your Stripe billing to go to an actual URL there. And actually clicking on upgrade here will take you to a Stripe checkout page to actually implement your billing. And so you can implement all of that yourself. This boilerplate essentially solves a little bit of it for you. So that's the high level point of building a SaaS application. Once you build in limits here, you can go ahead and brand this and build it out as your own SaaS product. And so this is all possible in Flask with not too many lines of code, and it's all fairly understandable once you get into the code. I hope that has helped convince you about the value of Flask and its particular use case in the building large SaaS applications. With that, I'd like to close up. So you can find all of the source code for this example SaaS application that I've created here, and you can extend it and try and build your own application on top of it and try and play with it. You can also use this example as a somewhat large Flask application and how it's structured to help you scale. You can find me on Twitter at my handle here or on github.com/Sumukh for some of my other content, or if you have issues or questions, feel free to raise an issue. Thanks so much for your time, everyone.